All right, let's talk about something in JavaScript that messes with pretty much everyone's head at some point: hoisting. It's this behind-the-scenes magic that can lead to some really weird bugs if you don't know the rules of the game. So, let me just throw a question at you. In most programming languages, if you try to use a variable before you've even created it, that's a big no-no, right? An instant error. But JavaScript, it does its own thing. Take a look at this snippet. We're trying to log the value of x before we declare it and assign it the value of 10. So what do you think is going to happen here? Will it crash? Will it magically know the number is 10 or something else entirely? And the answer is undefined. Now, this is where it gets interesting. The key thing here is that it's not an error. That means JavaScript somehow knew about the variable x already, but it didn't know its value yet. So what in the world is going on? Well, my friend, the answer is hoisting. Yeah, that weird behavior we just saw? It's all because of a core JavaScript mechanism called hoisting. Let's really dig into what that actually means. Think of it like this. Before your code even starts to run, the JavaScript engine does a quick first pass. It scans through everything, finds all your declarations like var x or the name of a function, and just kind of shoves them up to the top of its memory. It's like it's getting all its ducks in a row before the show starts. Okay, so here's the absolute key when it comes to var. The declaration, the var x part, gets hoisted. It gets moved up. But the initialization, the equals 10 part, that stays exactly where you put it. This separation is the secret to our whole puzzle. So this is what's happening behind the curtain. On the left is the code you write. But on the right is how the JavaScript engine actually interprets it. It takes var x and effectively puts it right at the top. So when it gets to console.log of x, the variable x totally exists. It just hasn't been given its value of 10 yet. And that's why we get undefined. The assignment happens later, right on the line where we originally wrote it. But of course, it couldn't be that simple. Modern JavaScript introduced let and const, and they decided to play by a whole new, much stricter set of rules. This is where things get even more interesting. So let's run the exact same experiment, but this time with let. We log y, and then we declare it. Based on what we just saw with var, what's your gut feeling this time? Is it going to be undefined again? Nope. This time, we get a hard crash, a big reference error. And look at that error message. It's super specific. Cannot access y before initialization. This tells us something really important. JavaScript knows y exists, but it's like there's a force field around it, telling us we can't touch it yet. And that force field has this awesome kind of sci-fi name, the Temporal Dead Zone. From the start of a block of code until the line where the let or const variable is actually declared, that variable is in the TDZ. It's been hoisted, but it is completely inaccessible. This chart sums it all up perfectly. With var, the variable is hoisted, and you can access it. You'll just get undefined. But with let and const, they create this wall, the Temporal Dead Zone. The variable is still technically hoisted, but it's completely off limits until you reach its declaration. Trying to access it early is an immediate error. It's a safety feature, really. Okay, we've got variables down. Now let's throw functions into the mix, because hoisting has a little twist for them too, and it all depends on whether you're using a function declaration or a function expression. First up, the classic function declaration. Look at this. We're calling the greet function on the very first line before we've even written the function itself. This just feels like it should break, doesn't it? But it works perfectly. And that's because function declarations get the VIP treatment. They are hoisted completely. Not just the name, but the entire function body gets moved to the top of the scope, ready to be used from anywhere in that scope. Okay, now for the other side of the coin, a function expression. Here, we're creating a function and assigning it to a variable. Say hello. And notice we're using var. That should give you a big clue about what's about to happen. And we get a type error. Now, this is different from the reference error we saw with let. The error isn't that say hello doesn't exist, it's that say hello is not a function at the moment we tried to call it. So why the type error? Well, it goes right back to how var works. Only the declaration var say hello is hoisted to the top. So when the code tries to run say hello, the variable exists, but its value is still undefined. And since you can't call undefined like a function, JavaScript throws a type error. Okay, we have covered a lot of different rules and weird edge cases. So let's bring it all together into one simple guide that you can use as your master key. This table is your new best friend. Seriously, let's just run through it. For var, it's hoisted, but its value isn't. You can access it early, but you'll just get undefined. For let and const, they're also hoisted, but they're locked in that temporal dead zone. You cannot access them before their declaration. You'll get an error. Function declarations are the special case. Both the name and the body are hoisted. They are fully accessible. And finally, function expressions, they just follow the rules of the variable you use to create them. Simple as that. So let's lock these key takeaways in. Var is forgiving, but it can lead to those tricky undefined values. Let and const are much stricter, protecting you with an error. Function declarations are the most powerful, being fully hoisted and ready to use anywhere. And function expressions are simple. They just behave like the variables they're assigned to. Remembering these 4 rules will save you countless headaches. And this is really why it matters. This isn't just some weird trivia for a job interview. Knowing the rules of hoisting helps you understand why your code is behaving the way it is, which lets you prevent subtle bugs and just write cleaner, more professional code. So the takeaway is pretty clear. While you can rely on hoisting, the best practice is to always declare your variables and functions at the top of their scope before you use them. It just makes your code more readable and gets rid of any surprises. So the question is, how will this new understanding change the way you write your next line of JavaScript? Thanks for watching.